Alright, making another video on the subject of this wave interference thing. The interference of energy at a frequency. The whole concept of how we measure it, how we see energy, why we see it, how we detect it. As I've attempted to get people to understand, I think, is there's a simple way to view it, in my opinion, and a complex way to view it. So there is a simple explanation that there's this stuff called energy moving the speed of light, and it can take many different kinds of forms: gravity, magnetism, electricity. It can have frequency, it can have no frequency. It's little bits of energy, quanta. It hits something, like an electron. When that electron reacts, that changes something, like the pressure in the atom, changes its potential, creates something called electricity. So the movement is converted into another thing moving. So essentially the movement turns and moves in another direction. So the photon is absorbed and moves in another direction. And we can detect its new direction, a new flow. We can force it to hit something and move something, and when it hits something and moves something, we can detect it because we can create different kinds of levels of potential. Now, one could argue that this pen and this pen have the same potential because I haven't done anything special to one of them, haven't changed them in some way. So I can't make sparks between them because there's no difference in their potential. And the ground and this pen, they have the same potential too, because they're getting hit by all the same forces. They're the same temperature, essentially. The same amount of energy is bombarding them and pressurizing them. So they're sort of at the same pressure, is a way to look at it. The same atmospheric pressure. So you can't make a spark. You have to somehow change their internal pressure, okay, for there to be a potential difference. A difference in their potential between them. And then you can make a spark. Then you can make something happen. Alright. Alright, so the concept is this wave stuff is just an illustration of the fact that there's stuff at a distance. That it happens. An event happens and there's a time lapse between the events. However you want to look at it. I mean, I think Feynman would like that better. This energy stuff is sort of clumpy. Now, you don't have to believe that. You can think that it turns on and it turns off in some gradual way, but the whole definition of quantum mechanics was basically to say, no, it really doesn't have progressive on and off. It's either there either is something or there is nothing. It comes in clumps. Yeah, I mean, I can't force you to recognize that as true, but I mean, that's what all the real evidence points to. And, this wavy stuff just isn't really clumpy. All right, now the other problem is so when you're saying that these clumps are somehow going to interfere with each other and do something, there's this notion that somehow they can destructively interfere, the clumps themselves. And so there's very little evidence that light bangs into light. You can shoot laser beams right into each other all day long, and no photons will fly off in some funny direction. It just won't happen unless there's particles in the air. The photons themselves won't interact. And there's no, I can put the biggest magnet in the universe next to a laser beam and I can't bend it. I can't move these things with these things. I can't use things moving the speed of light to move things that are moving the speed of light. It just won't work. Just no evidence of it. Now, they believe that gravity can, but they don't have any good evidence that that's true. I mean, just none. And that's it. That's the only evidence, if there is any, that exists, demonstrating any ability to manipulate these things by banging them into each other. So they have this problem. So in the light experiment, for example, we're to believe that somehow a single photon, well, let's forget it, right? This just doesn't make any sense. So let's not waste our time on the single photon nonsense. But the point would be is that you kind of understand that the light that goes into the experiment, the energy isn't destroyed. That light is energy. and you can't destroy it. So you really can't make it destructively interfere. That's why shooting two laser beams at each other doesn't make the light disappear. It goes back into the other lasers. You can just have them a little bit off center. The laser beam keeps going. Nothing's destroyed. So you can't destroy the energy. So in the photon experiment with the slits, apparently, in particular, you can sort of understand that the light that goes in really does all hit somewhere. It just all hits where the bars are. So the light that would have been going to the dark spot doesn't go to the dark spot, it goes to the bright spot. And so you can always understand that the energy's still there, just going someplace else. Now, that works for photons in the light experiment because it's a slit and there's something to deflect the light, which is the surfaces. There are refractive indexes in those surfaces. So it makes sense that those surfaces can bend light, just be how light bends when it goes into water and it bends. Same difference, how it bends in a prism. Well, you shoot the light along the surface, it'll also get bent. That's the refracting element. Now, you don't have to believe that, but I'm just saying it's a perfectly rational explanation versus some notion that you're making photons hit each other and deflect or something, go somewhere else. So the problem with this animation is, even though it's supposed to be showing interferences, this is only true for interference in a medium. So this little animation is true for water or for sound, because that red line is actually double the amplitude. But if you were doing the light experiment, the truth would be is that red line should be 4 times bigger, because really the light that isn't going to the dark spots is actually going to the light spots. So there's actually 4 times as much light there, not just twice. If you're going to be fair, if you're going to accurately describe what the reality is. So this animation is not even accurate in the sense that when the two things, the red and the green, all right, are mixing one way, right? They're saying, well, when they mix one way, when they're on top of each other, superimposed, or on top of each other, then we say that's double the amplitude. But somehow when they're this way, okay, they don't have any amplitude, they're nothing, when they're interfering. And like I said, we kind of know that no, the energy is conserved because the photons aren't in a medium. They can't crash, the Earth into the if the Earth is going this way and Venus is going this way and they crash into each other, you can sort of understand how. Well, you can sort of understand that if they were going to stay in one piece, then they'd kinetically just go off in their exactly the same vectors. The energy would be completely conserved. Or if they were soft, you could see they could mold into each other, and all the energy would be canceled in a way that all the stuff moving this way would hit stuff moving this way, and they would sort of undo each other's energy. But even that doesn't really work. But anyway, but in mediums, that's what's happening, right? A piece of the rope, say if this was a rope going up and down, there's pieces of the rope that are moving up, and there's pieces of the rope that are trying to move down, and those things hit each other and nullify the effect. It becomes stop because you're going the equal amount of speed, and it equals stop. How else to say it? Yeah, so it's in mediums. Mediums are incredibly important to this conversation. So if you don't understand that there's nothing tying photons together, the photons aren't connected. They can't pull each other somewhere. They can't drag each other somewhere. They can't undo each other's. You can't yin and yang with photons and have nothing, and have them undo each other, undo the effect. That's another way to say it. I mean, you can bounce a ball. You bounce the ball down, the Earth pushes back up, pushes the ball back to its original place. You end up with 0. Okay. The pendulum swings. You end up with 0. You start here, you swing, 0 again. Photons don't do that. Energy doesn't do that. So, yeah, that's probably enough, and then I'll get to I'll just do the rest and try to illustrate some of the problems in being certain exactly what's going to happen when photons hit something. So Holliday's still arguing, defending some notion that he can create standing waves out of photons, standing waves that don't plow right through things. That somehow the energy isn't moving. That it's somehow the energy is only in certain locations, and other locations will be undisturbed. And there's just, in my opinion, there's just no way you can make a photon create any such illusion or do any such thing, because it ends up moving through every piece of space between point A and point B. So, if you have two things and you're moving a photon in a direction, the photon, even if you're doing it at a frequency, you shoot one and then you shoot another at a time interval, and then you shoot another at the time interval, and you shoot another one at the time interval, there's just no way to, each photon will go through every bit of space between point A, okay, and point B. I mean, every single piece of space between those 2 points, it will plow through. And it doesn't matter whether you're shooting another photon in exactly the opposite direction. You can't make the photons stop anywhere and just go up and down or something, or just say I'm a photon here and I'm not going anywhere. I'm not going to point A and I'm not going to point B. You just can't do this. I mean, logically, it just doesn't. I don't know why he thinks that makes sense. I don't know why I don't have an eraser here. It's not very bright color. Well, whatever, we'll work on it. All right, so in this radar experiment, the things, okay, so as I pointed out, the animation only shows, yeah, I guess I can get it back. It's basically saying that it's only showing us half the energy. The red line only has half the energy. So of what's actually happened of the two cycles. So there's only a certain period of time that you have twice as much, and then you have nothing. And you really, because it's two waves, you really have to have 4 times as much and then nothing. Okay, to account for the wave. And the same would be true in this radar experiment. The idea that the radar actually destroys itself by interfering isn't really compatible with what we know about energy. Energy can't be destroyed. So the energy can't be nullified. So it must be going to the other locations. And they sort of hear that in the audio tone, which fools them, because the audio tone has this 4 times difference. So they think the 4 times difference is caused by this effect when that's caused by the amplification process, as I've pointed out. But then then Hoffler has to understand that this standing wave is an illusion, because the null points really aren't nothings. There really is something there. So he can't evade. Again, it's like saying that somehow you could be shooting cannonballs at something, and somehow you could sit in locations where no cannonballs are going through you. That sometime if I shoot cannonballs this way at each other, that somehow I'll create a standing wave of cannonballs, and now I could walk through the cannonballs. It's just nonsense. They're going to move through every bit of space. You can't stand somewhere and say, I'm immune to being hit by cannonballs in the stream of cannonballs. It just doesn't make any sense. All right. All right, so back to the real particulars. All right, so the idea is what we're talking about now in this radar thing is that they have an antenna. And so now we have to understand, well, what is an antenna doing? Okay, how's this thing work? And I'm arguing that bits of energy hit the antenna, and as they hit the antenna, they are converted quite directly. This frequency ends up being converted from a frequency as a force, photons, into another kind of force, electricity. And electricity is essentially like photons. Okay, I mean, it's similar to a photon force in the sense that it has a high speed, but it's a little bit smaller than the speed of light. Because we sort of, the theory is, see, again, these theories are very undeveloped, but the theory is that the electrons are in the atom, and that what's really happening is the electrons don't move with the electricity. That what they really do is they move a little bit, and their force between them is pressurized, and that pushes the next electron a little bit, and that pushes this electron a little bit. And so they cascade. They push, almost like this pen, they push on one end, and it moves at the other end. Okay, but there's no electrons moving in an electricity. It's not a pen, obviously. And so there's some compression of the electrons, and it's the compression of the electrons that really moves between them. And so we've just taken the force and basically rerouted it into almost still the same speed, but a little slower. And now we have it moving in between electrons. So the force moves in between the electrons, and the part that slows it down is just the fact that the electrons move much slower than the force does, the photons. So it's the same energy, it's just now pushing on electrons. When it pushes on an electron, the electron's force hits the next electron, then this force hits the next electron, so the force is pushing it. So it's essentially the same thing. So the frequency that went in is sort of retained in this force that's pushing the electrons. And so, like for example, the high tension wires that can collect a radio tower signal, and then you can hear the radio in the spark gap, because the spark gap is vibrating the atmosphere at exactly the same frequency as the towers being turned on and off. The electricity is being turned on and off at the same cycles of the music. And as the electricity is turned on and off, the atmosphere is being pressurized at exactly that same frequency, and so we hear it with no radio. All right, so it's kind of a simple idea that what you're doing in the antenna is creating an electrical potential. So the antenna, whether you have it tied to ground or not, through a circuit, you're testing a plus end and you have a ground circuit, and you're going to measure the difference between its positive potential and this ground. Shouldn't really tie it to this antenna here, but you're just going to basically move. You're going to take the potential. I'll just erase that now. Make it less illusionary. How did that dry so quickly? Annoying. Anyway. Oh yeah, so I'll put the ground somewhere where you can see it. And so there's ground here. And that's going to be our neutral. Because as sort of stated, the antenna and the ground before the photons started hitting it. So let's just say that everything's always getting hit. So the antenna is getting hit. So I haven't turned on, here's a radar dish, and I haven't turned it on yet. And everything has a certain amount of energy hitting it. And the antenna has that energy, and the ground has that energy. So they're at equal potential, but they're basically getting hit by the same amounts of energy. But now when I turn the radar dish on, I'm going to be adding these new photons, all right, at specific frequencies, at a specific frequency. And then we'll have another dish, let's say. Let's put one over here. So we have some space for drawing it over here. All right, so we'll get rid of the electron drawing. It's just in the way, I think. Not perfect, but good enough. Yeah, my green is getting pale. I have to get a new green. All right. So we're going to send now this force into the antenna. So now it's going to create more electricity. These photons will essentially go into the antenna, push the electrons. The electron push will be transferred between the electrons, and you'll see these photons here as potential, as electrical potential. And it'll be each photon that hits is a little nudge, a little press on a Morse code key. It's a little press on the key, a little press on the key. On. Okay. And now the theory now would be is, well, what can you do with this information? So if these two are hitting the antenna at exactly the same time, you know, both antennas are shooting energy and the photons are at a frequency, and they hit the antenna at exactly the same time, well then all the little on-offs, all the dots, all the key on the key is going to go on, off, and it's going to go on, off with a higher electrical potential because you have dots at exactly the same interval, same frequency, and so you're just going to get you'll be able to detect that. Say if you put an amplifier on here, what's it going to do? It's going to say, well, there's this much noise. Screw all the noise. What do I hear above the noise? What do I hear above ground? And what it's going to hear is this stuff that's louder than the noise. That's not. The antenna's getting more of it than the earth is. It's one way of looking at it. Yeah, the antenna is a conductor. What else do I say it? Well, anyway, it's gaining more potential because it's more in where the radiation is. It's receiving it. It's poked into it. That's why people put their antennas on the roof. It's because they work better. Because they're poked into the energy field. All right, so let's say they're out of phase. So now you're not going to have this, you know, the electrical jolts, okay, aren't going to be both at the same time. So in the Morse code key example, now it's not going to be dot, 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 dot. Now what the antenna is going to be saying is dot, 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 dot. It's going to have twice as many. There's going to be a dot in between the dead spaces because now they're out of phase. So now you're going to have a weaker signal, right? Less voltage, and it's going to have more dots in it. You know, the frequency is going to be essentially higher. Now the question is, there's some point where the key going up and down can't go any faster. It's mechanically limited. So if you combine two frequencies, the key can't bounce that fast. So you won't be able to receive the signal as dots, because the key, when it's up, it's already gone down. It's already it's already got another cycle, and the key hasn't even gone down yet. It hasn't relaxed yet, so you can't pressurize it. So you're faster than the impedance of the system. The system can't react because it's too slow. So that's one liability. That there might be a limiting factor to how much you can. How high a frequency you can create by mixing two things that come in. The electrons, the mechanism, even the clumps, thickness of the clumps is too thick. So even though you have the two, if the two clumps are too thick, right, and they're separate like this is how thick the clumps are, so the one signal is this far apart, so there's no real problem. But when you combine them, then they'll end up overlapping the clumps, and so you won't be able to tell. There won't be any off. They'll just be on. And you have like a DC voltage. You won't have any frequency in the voltage, and so that's a little harder to detect because it has no trademark. It has no signature that makes it easier to find, because it's just going to be a tiny increase in the overall voltage, and it's going to be very tiny, you know, milliwatts. Yeah, so I just don't. Right. So yeah, I just know what to say. That, you know, the only question is you have to have enough energy, enough of this stuff hitting it, to create enough voltage in the antenna so that you can receive it. But I mean, the theory is as simple as the Morse code key clicker. And so when they're in phase, you get nice solid clicks. When they're out of phase, you just get quicker clicks, and they're weaker. And that's really all there is. It's not like you really made a new frequency. It's just that the only way it can be interpreted, because it's turned into electricity, is the electricity is going to be on, and then on, and on, and on, and on. You know, it's going to be quicker. It's going to have more pulses in it. So it's going to be a fact. You know. So yeah, so I don't know how it can really be described any other way. What other mechanism you would call this thing called interference? So in this simple experiment that I've described, you know, where you just have the three elements, you know, 2 transmitters and 1 receiver in the middle. All right, it's kind of obvious that the energy from one is going to hit this. You know, it's kind of obvious. You can't miss getting hit, right? You knew if this was a flashlight and this was a light bulb and a light bulb. You know, if you stood here, it doesn't matter where you move this stuff. You know you're going to get light hitting you. You just can't avoid it. You're going to get hit with the energy coming off the light bulb. And so the only question is as I move things like this, what I'm going to do is change the phase of that dot, 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 dot. So if I'm in the right location, I'll get the key will go, because both of them will be hitting at the same time. This, I'll get hit at the right and I'll get hit at the left at exactly the same time, each pulse. And so the key will have a nice click, 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 click. But if I start to move them a little, then the clicks will start to overlap. And there's some perfect point, you know, where you're half phase, out of phase, where you'll get twice as many clicks and on this receiver. And the only question is actually being able to receive the energy. But clearly the theory that that's what the energy is going to be doing, I don't see how anybody can dispute that. That's exactly what the energy is going to be doing. But it's not going to matter how much energy hits this. Can't be changed. You can never change how much energy is hitting it, because the closer I go to this one, the more intense the energy from this is. The closer I go to this one, the more intense the energy is from this one. So no matter where I move in here, I'm going to get hit with exactly the same amount of light. I mean, there's no place I can go where I'm going to get hit by less light, or I'm going to get hit by more light. There's just no way to do it. It's like the gravity argument inside a hollow sphere. The gravity is the same everywhere, because the closer I get to one side, the further I am from the other side. I've made it weaker and I made this stronger. And the closer I get to, I made this one stronger, I made this one weaker by exactly the same potential. So no matter where I move in here, I'm going to get hit with exactly the same amount of energy. So Hathaway has some idea that he can move something and somehow have less energy in different locations. He just can't. And even if you use the 2-gun idea, okay, 2 guns coming at you spread this way, and you're saying that they're interfering with each other and there's dead spots, as I'm pointing out, no, there really aren't dead spots. Okay, the energy's there. It's hitting the spot. You just can't receive it there because it's not going click, 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 click. It's going click, 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 click. I just don't know how you can't understand how that explanation fits the facts pretty completely. So, yeah, I think I've gone over the rest of it. I think Steve, I guess I'll talk to him for a second. I think he knows, basically, he can do the experiment lots of different ways. And it's his choice how he wishes to proceed. I guess I don't know which ones are the most, you know, the first things first, or what you can prove the simplest, the quickest. You know, I suppose would be looking for the higher frequency, just to see if there isn't some phenomenon. See, I mean, the real question is well, I don't even think it can possibly be made into a question, actually, because I think the force is, the force that hits the antenna is kind of accurately represented in the voltage. And if it wasn't, radios really wouldn't work. Lots of things wouldn't really work. So it sort of has to be there as a frequency. Whether you're, and the thing is that, you know, when you're tuning to something, I mean, all you're doing is letting it hit something. You're sticking something up in a field that has stuff that's vibrating, and you're saying, how's it vibrating? You know, and the antenna is pretty accurate at picking up the vibrations. So it really should be true to what's happening. All right, so the idea is to have the two transmitters. Obviously, I'll just draw it this way to make it look funny. Okay, all right, so, and you're sending the radiation out. And now the question is phase and in phase. And really don't have to worry about it. So, you know, all Steve has to do is put two radar dishes, you know, an antenna in the middle, and the first thing to say is, can he just measure the absolute potential difference? So can he just take a voltmeter and see the voltmeter go up when these things are on? Turn one on, see if he can measure the voltage. Turn the other one on, see if he can measure the voltage. And if he sees the obvious, turn this one on, he'll get a voltage that's here. Turn this one on, now they're both on, he gets a voltage here. I mean, that's the simplest thing to do first. It's just see if you can measure the voltage. And then the second thing would be to hook this up, this antenna, to his fancy frequency counter and see what he reads. So put on one of the dishes, see if he reads the frequency. Put on the second dish and see if it either interferes or doesn't interfere. If it kills this reception of this frequency, then he knows he's destructively interfering. So he moves one of the dishes until he gets the frequency back in phase. And then he can move to a higher frequency and see if, when he moves it back to the dead place, the place that wasn't working, is there really dot 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 instead of dot dot dot. He'll just see if that higher frequency is there. And the only thing that could prevent it from being there, as I stated, was that if the lumps are too big, right, then if you put them if you increase their frequency, see, if the lumps were this big, you can sort of understand now, if I double that frequency, then I'm going to end up with lumps overlapping lumps, overlapping lumps, overlapping lumps, and I'll have no frequency. I'll just have energy and no frequency. So that's the only catch that might mess up falsifiability or something. But anyway, like I said, we should be able to glean quite a bit of information from just this simple experiment. And then you can start doing it with the two and doing all kinds of different variations on either measuring just the raw energy, the electricity in the wire, or attempt to detect the different frequencies that might be being collected by the wire. But lots to play with, and it's amazing, you know, that in the last almost 100 years, nobody's cared to do any playing. Nobody's cared to really analyze. The people who had this equipment haven't done anything with it to see what would happen. Not that they're revealing it to us. I think they do know what happens. I think they know the experiment doesn't work. Okay, they can't show interference if they do it the way I'm describing. And so they say, oh, let's not do that because that doesn't show interference. It shows energy hitting the antenna. We don't want to do that. We don't want people to see that because that doesn't defend our theory. And so they've only showed us the manipulation of the experiment that makes it look like they're right. They don't show us the arrangement of the experiment that makes them look wrong. Alright, that's probably enough. Again, this hostility thing with Hathaway, I mean, he does it in all his videos. I try to ignore it, but I don't know why I'm obligated not to react to it. I just don't accept this excuse that somebody has some Asperger condition, and they're going to say, well, I'm a rational and reasonable person. I can have highly intelligent conversations by lots of subjects. but I can't understand that I just called you a liar and that you might be offended by that. I mean, I call bullshit on that. So if he says, look, he can understand atomic theory and he's going to understand these concepts of standing and traveling waves. And again, these things aren't waves. So again, you people who want to keep calling them waves, I'm just saying, will you please be honest and say then that you believe in an ether, that you believe there's a bound matrix in the universe of stuff that's tied to each other, creating a fabric or creating a fluid that's bound. And so the fluid has to move. When one piece moves, all of the fluid moves, or some kind of crap like that, because that's the only way it can work. So I just hate this dishonesty of saying you're particle physicist or you're not etherist, when your whole view of how it works is dependent on you creating a bound medium. Waves happen in substances where the particles are connected to each other. It's like you can't make waves travel through sand, okay? Because the grains of sand aren't connected. They won't play along. They won't travel anywhere. So you have to understand that you just can't play this game that you're saying it is but it isn't. So you either just say you believe in ether. Just admit it. Okay. I think that's probably enough. So on hospital, like I said, I really have no desire to keep having this tension with people and this hostility. It's just not my preference, and I'm saying, how much of abuse am I supposed to just keep taking and say it's okay? You can diss me, you can keep dissing me, you can keep dissing me. Yeah, there's a point where I take 7 years of this crap, and it's not like I'm holding grudges. I'm saying, okay, there's just absolutely no evidence that if somebody treats me with the least bit of respect, that I don't also treat them with respect. I mean, this is just such crap. Well, anyway. Till the next time and such. I mean, communication is just so fucking obnoxious a process. So, the animation one more time. Like I said, see, if this was describing the interference pattern in light, let's say, in the two-slit experiment, this is what we're going to say this is an illustration of. Most logical people would say that, oh yeah, well, you sort of have to fix that because those red lines have to go longer to account for all the humps, because the energy really did just move to the places where it landed. It's not like the energy was destroyed. The photon didn't go in and not go somewhere. All of the photons went somewhere where we saw them. So, it's a subtle but really important to understand how this works. And the radar people are being quite aware of that, because they know when that audio signal changes, there's a 4 times difference. So they're more aware of the fact that, oh yeah, these photons are actually moving to a new location. They're not really destroying each other. They move to a different location. And they don't have really any theory for that. They have no theory for how the photons move to a new location. I mean, it's such weak theory. Ugh.